In this video, we'll be doing the next free response on on page 15, 2013, number 4. And so it says the figure in the above shows the graph of f prime. So again, as soon as you see that, you need to make a mental note. What are they giving you? F prime, not f, but f prime. The derivative of a twice differentiable function f just means you can take the derivative twice. On a closed interval from 0 to 8, the graph of f prime has horizontal tangent lines at 1, 3, and 5. The areas of the regions between the graph of f prime and x are labeled. The function f is defined for all real numbers and satisfies f of 8 equals 4. So they're giving you an initial condition. That's probably important. Let me go ahead and label that. It might help if you start doing that too, so you don't forget, because it's easy to forget about that little piece. We might not need it right away, but we're probably going to use that at some point. So part A says find all values x on the open interval where the function f has a local minimum. So where do you have a local minimum? When f prime switches from, if you draw a minimum, it might help. The slope at a minimum switches from negative to positive. So we want f prime to switch from negative positive. So where on this graph does f prime, because it's negative beneath the x-axis and positive above the x-axis, so we're looking for an x-intercept that switches from negative to positive. So this is an x-intercept, but it doesn't switch. This is an x-intercept, but it goes from positive to negative. So that wouldn't be a minimum, that would be a maximum at that point. This is an x-intercept that switches from negative to positive values. So what is that value? That is at 6. So part A, you would write out at x equals 6. I'm trying to use my sentence so I word it good. F will have a local, which is the same thing as relative. You could write relative as well. Minimum. And then you write out because f prime of x, notice I didn't say the graph, but f prime of x switches from negative to positive. And that would suffice as justification if you wrote it out in words. Do not use a sign chart for justification on relative maximums. Part B says determine the absolute minimum on an interval. So this looks like another one that might take a while, but maybe it'll go faster than the last one. So we're looking for an absolute minimum on a closed interval, 0 to 8. So how do we start off those type of problems? Is first you need your critical values, right? So you need, and what are we talking about? We're talking about f. So we need to know when f prime of x equals 0 first, which is what we have here. So when is f prime equals 0? At 1, 4, and 6. Now, you could use, that's a lot of critical values, plus your endpoint 0 and 8. That is a lot, and you could do all that and you would get the right answer. Now I will tell you something to save time. It's a minimum, so you only really care about the relative minimums, right? Okay, if at 4 that's a maximum, that's not going to be able to be an absolute minimum. It just doesn't work out that way. You technically only care about the relative minimums and the endpoints. Or if this was maximum, we only care about the relative maximum and the endpoints. But if that confuses you, you could still test all these numbers and it'll work out the same. So either one you want to do, I'm trying to decide which one would make more sense to y'all. I think I'm going to do all because I don't know if y'all would recognize that you could do that, but for those of you that understand what I'm saying, go ahead and you don't have to do the 1 or the 6. So remember, you plug them into the original for absolute. min and max. You have a critical value at 1, 4, 6, and then our endpoints are 0 and 8. And we're plugging them into the original. Now pause here. Do we have an original? So anytime they don't give you the original, but they give you the derivative, you're going to have to write your own original. And this is how you come up with your own original. This, I wouldn't write all this out on my free response. I'm making notes for y'all. So, when given f prime of x, and you need f of x, you're going to use this setup. F of x equals the initial condition, which is f of a, plus, and now how do you go backwards? We know this. You integrate, right? If we have f prime and we're trying to go to f, you integrate from a, and now we use that boundary as x. You can plug in, that's like your f of b, of f prime, and this is where you use t, just so that it's not the same boundary, but they would not take off if you use x. But technically you should change that to t, but it's still the same f prime of x graph. So what do? We just integrated to go backwards from f prime to f, but you have to add that initial condition. If you forget that initial condition, it's going to be wrong. So this is something you need to like memorize. So why did we highlight this initial condition? We're going to use it to come up with our f of x. So in this problem, our f of x equation will equal f of a. So what is that? That's the y value, which is 4, plus the integral of a, which is the x value that went with that. So that's 8, right? This is, a is inside the parentheses. What it equals is f of a. So 8, to keep that x, that's what you're plugging in, of your derivative. So now I probably didn't give myself enough room to write out all my work for this. But we would first do f of 1. So that would equal 4 plus the integral from 8 to 1 of f prime of t, or x. So if you notice, the boundaries are flipped. So you would want to negate it. So it'd be 4 minus the integral from 1 to 8 of f prime. So we have our f prime, and they give you the area, so that's how you're going to evaluate this integral. From 1 to 8. So 1 is here, 8 is here. So that is, and don't forget this area is like a negative 30 because it's underneath. So that total integral would be 6 minus 3 is 3, plus 7 is 10. So it would be 4 minus 10, which is negative 6. Okay, and you're going to go through and do it for all of these. Now I'm probably going to get off, but I, again, didn't give myself enough room, so I'm going to draw some lines. Now 4 plus the integral from 8 to 4 of f prime of t. I need to switch my boundaries again because my a is bigger than my b. So 4 minus the integral from 4 to 8 of f prime. Okay, so go to our graph from 4 to 8. That'd be negative 3 plus 7. So that would be a positive 4. So that would be 4 minus 4, which would be 0. Okay, that is for 4. Now for 6. 4 plus the integral from 8 to 6 of f prime of t. So I need to switch my boundaries still because my a is bigger. So 4 minus the integral from 6 to 8 of f prime of t. So 6 to 8 is here. That's an area of 7. So my integral is 7. So 4 minus 7, which is negative 3. Okay, y'all do 0 and 8 real fast while I let my dog out. And 0 should have been 4. And hold on, let me draw my, it's getting real cramped. 4 plus the integral from 8 to 0 of f prime of t dt equals 4. 0 to 8, you need to still switch it. So minus 0 to 8. So 0 to 8 is all of it together, right? So 2 plus 6 is 8, minus 3 is 5, plus 7 is 12. So that would be 4 minus 12, which is negative 8. And lastly, we're doing 8. So 4 plus the integral from 8 to 8. Well, we know if the boundaries are the same, if a equals b, that integral is 0. So that would just be 4. Which you already knew that, right? Didn't we know f of a equals 4? That's our initial condition. So we have all these y values we can compare. Negative 6, 0, negative 3, negative 8, and 4. And we're looking for our minimum, so which one's the smallest? It would be negative 8. So did it ask for the x value or the y value? It says determine the absolute minimum. Not where, but the minimum, which is the y value. So we would say the absolute minimum on whatever the interval was, which was 0 to 8, is negative 8. If it said where is the absolute minimum, you would say at 0, the x value. Okay. So then C says on what open, can y'all see it? On what open intervals contained in the interval in the graph of f is the graph of f both concave down and increasing? So we're determining when is, oh, I should have even boxed f. F concave down and increasing. So we're determining concavity and is it increasing based on f prime. So I would actually do increasing first, because that one to me is a little easier. So how do we know when it's increasing? F is increasing when f prime is positive, right? So positive is above the x-axis. So we're only looking up here. That means we don't care about this little section down here because it's negative. It's not, that would be when f is decreasing. Now, the other requirement, though, was it has to be concave down. So how do we know concavity from f prime? Because we know it's when f double prime is 0. When f double prime is negative. So what does that mean for f prime? That's when f prime is decreasing. So where in this positive section is f prime decreasing, going down? It'd be here. Then it's increasing, and then it decreases again here. That's negative, and then it's increasing again in the positive. So we have two sections we highlighted. From 0 to 1, and from 3 to 4. So then those two intervals, f is going to be both concave down and increasing. So how I would word this is, first give your answer and then your justification. So I'm going to say f is increasing and concave down from, and now you can write your interval in any notation you want. I'll stick with the one they use, from 0 to 1 and from 3 to 4. I would do open interval. I wouldn't put equal to sign. But if you also use just parenthesis, comma, 0, 1, parenthesis, comma, 3, 4, that would have been fine too. Now, because you need to write out, if you make notes like this, that is, I would summarize it all in a nice sentence. Don't just leave it at that. But we're basically going to write this. F prime is positive and f prime is decreasing. F prime is positive and f prime is decreasing. And that should suffice for justification. Okay, last part says the function g is defined by, it's a composite function, f of x cubed, and then it gives you a value that you're probably going to need. F of 3 is negative 5 over 2. Find the slope of the tangent line to the graph of g. So we're using this function at x equals 3. So what is the slope of a tangent line? Slope of the tangent line is the derivative at that point. So how do you find the slope of a tangent line? Is you take the derivative and plug in your x value. So we're going to have to get the derivative of that composite function, right? So g of x, I'm going to go ahead and write it. You don't have to rewrite it on your free response, but just because I'm on another sheet of paper, is f of x cubed. So how do we find g prime? What rule would we need? You should think about that before you start. It's chain rule, right? Because you have something inside something else. So we're going to bring the 3 to the front, keep the inside the same, and then it would become a 2, subtract 1, and then you do times the derivative of the inside, which would be f prime of x. And now we want to know the slope of the tangent line at 3, so that means we're finding g prime of 3. And we just evaluate this. So let's see. F of 3 they gave us, right, is negative 5/2. So I'm going to make sure that's in parentheses when you square it. Times f prime of 3. Well, don't forget they gave you the f prime graph. So you just go get the point. At 3, f prime equals 4. And so then I'm going to square a fraction. When I square it, I know the negative is going to be positive, and then I square the numerator and the denominator. So that's going to become 3 times 5 squared is 25, 2 squared is 4, times 4. So I know if I'm dividing by 4 and multiplying by 4, those will cancel. And I really just have 3 times 25, which is 75. So that is the slope of your tangent line at 3. And I think that completes the free responses for that section.